Okay, in this video, we're going to try to evaluate this integral here. So it's the integral of sine x over 1 plus x to the fourth from minus 1 to 1, so a definite integral. Well, by the fundamental theorem of calculus, if we can find an antiderivative of this function here, we'll be in good shape. The problem won't be that difficult. So, first thing we might do is ask ourselves, can we just think of a function whose derivative is equal to sine x over 1 plus x to the fourth? And, well, I can't think of any such function. So, that means that we should go to one of our integration techniques. At the moment, we only have one integration technique, that being the method of substitution. But, try as you might, letting u equal one part of this function, du is not going to show up elsewhere. So the method of substitution is not going to work with this integral. In fact, even at the end of the class, I don't believe that we'll have any method to actually find an antiderivative of this function sine x over 1 plus x to the fourth. Well, does that mean that all is lost? Well, no, not necessarily, because what you might notice is that in this case, we're integrating from minus 1 to 1. And whenever you have a definite integral where the lower limit of integration is the negative of the upper limit of integration, it may be possible to use the symmetry of your function to evaluate the integral. In particular, if our function here were even, well, this integral would be twice the integral from 0 to 1. If that were the case, though, we would still need to find an antiderivative of this function. Better still, though, is that if our function is odd, we know that the integral of this function from minus a to a, where in this case a is 1, is going to be equal to 0. So let's see if this function is odd. Alright, so let's just write this down for ourselves. So let's just recall that if f of x equal to sine x over 1 plus x to the fourth is odd, meaning that f evaluates the negative of x as the negative of f of x, then from our handout number 6, we'll know that the integral of our function f from minus 1 to 1 is equal to 0. Okay, so let's see if we can actually show that this function here is odd. Well, for this, just recall that, in fact, sine x is odd. That sine x is, in fact, an odd function, meaning sine of minus x is always equal to the negative of sine x. Well, if you want to recall why, well, it's just like this. Draw myself a unit circle. And if you give me a value theta, then sine theta is this value right here. Minus theta is then this angle, and sine minus theta is then this y-coordinate here. So sine theta, remember, is just the y-coordinate of that point on the unit circle at angle theta. So here we have sine of minus theta down here. It's this y coordinate. And what you notice is that sine of minus theta is actually the negative of this value here, which was sine theta. So this is equal to the negative of sine theta. Okay, so that's just by way of justification of my statement that the sine function is odd. Okay, so we can use this to show that our function f of x is odd. Right? So remember, f of x in this case was sine x over 1 plus x to the fourth, and so f of minus x is equal to sine minus x over 1 plus minus x all to the fourth, which is equal to, well, as we just said, sine x is odd, so sine minus x is actually equal to minus sine x, and because 4 is an even power, minus x to the fourth is just x to the fourth. But this is just equal to negative f of x. So, what does that mean? That means that f is odd. So we'll write that down. So hence, f of x equal to sine x over 1 plus x to the fourth is odd, and therefore the integral from minus 1 to 1, it's important that that lower limit of integration is the negative of the upper limit of integration here. But because of that, and because this function is odd, we can say, just like that, that the integral is 0. All right, so that's all. So, just to recall the point of all this, if you're trying to integrate a function from negative a to a for some a, as we have in this case here, well, you might be able to use symmetry. And this is especially important if you have no way at all of finding an antiderivative of your function. So if you can't find an antiderivative of the function that you're integrating, and it just so happens that the lower limit of integration is the negative of the upper limit of integration, well, if you can show that the function you're integrating is odd, then its integral is going to equal 0. As shown in class, if the integral is even, if the function you're integrating is even and you're integrating from minus a to a, well, then you can simplify things a bit, but not entirely. In that case, when your function is even, the integral from minus a to a of your even function is twice the integral from 0 to a of that same even function. But symmetry is especially important when dealing with odd-valued functions, as we saw here.